Welcome back to part 2 of our OSPF video series. In the first part, we covered the basics of OSPF, including its purpose, how it works, and its key concepts like areas, LSAs, and the OSPF-neighbor relationship. In this video, we'll dive deeper into the practical side of OSPF. We'll focus on configuring OSPF on Mikrotik routers, optimizing its settings. By the end of this video, you'll have a solid understanding of how to implement OSPF in a real-world network. So, let's jump right in and take your OSPF knowledge to the next level. If you haven't seen part 1 yet, I highly recommend watching that first, as it covers the foundational concepts of OSPF, including how it works and its key features. I've already set up the point-to-point connections between the main office, Office 1, and Office 2, along with the local LAN configurations. In this video, we'll focus on starting and configuring OSPF. Let's begin by configuring a loopback IP address, which ensures that the interface remains always up and does not go down. The Mikrotik router ID is assigned dynamically, and as you can see here, it has selected the LAN IP as the router ID, which is not ideal. We want the router ID to be based on the loopback IP instead. To achieve this, we'll configure OSPF to force the loopback IP as the router ID. In the OSPF version settings, you'll notice two options, version 2 and version 3. OSPF v2 is used for IPv4, while OSPF v3 is designed for IPv6. Now, we'll configure the OSPF area to designate the main office, Office 1, and Office 2 as the backbone or core network. The area will be set to 0.0.0.0, which is the identifier for the OSPF backbone area. The final configuration is the OSPF interface template, where we define the networks that should be included in the OSPF backbone area. I just want to ping Office 1 to ensure the point-to-point connection is reachable. You can add an interface with a network assigned to it, but that would require setting up each interface with its own network separately. Instead, I want to configure a single template for the network. Let's start setting up OSPF for Office 1, beginning with configuring the loopback IP. We'll assign the loopback IP to the router ID in the OSPF instance. Next, we'll specify that the area is part of the main office backbone area. And the OSPF template will include the point-to-point, loopback, and LAN prefixes. Now, we can verify if our OSPF neighbor relationship is established and ensure it performs dynamic routing to display the network prefixes. Great, we can confirm that OSPF is functioning correctly. Let's ping from the Office 1 LAN PC to the main Office LAN PC, and then from the main Office PC to the Office 1 PC to check if they are reachable. It's working perfectly. Now, let's disable OSPF to check if the connection is still reachable, and then re-enable OSPF afterward. We observed that when OSPF was turned off, the main Office LAN PC and Office 1 PC could no longer communicate. However, when OSPF was turned back on, the connection was restored. Let's set up OSPF on Office 2's Mikrotik so that the main Office PC and Office 1 LAN PC can reach the two server PCs. Let's check on Office 2 to see if we can ping the point-to-point IP of Office 1 and verify if it's reachable. Let's begin with the loopback IP. In the OSPF instance, we'll set the loopback IP as the router ID and configure it to version 2. Let's configure the area and specify that this router is in the same area as the main office and Office 1. Alright, in the template, we want to advertise the Office 2 network prefix so that the main office and Office 1 can see it. Let's check if we learn the neighbor, which is Office 1, and verify if OSPF is performing dynamic routing by examining the routing table. We can now see that we have learned all the routes, including the loopbacks of the main office and Office 1, as well as the point-to-point and LAN prefixes. Let's check if we can ping the two server PCs at Office 2 from the main Office LAN PC. Now, let's check from Office 1 to see if the Office 1 PC can reach the Office 2 PC servers. For the final test, let's check if the server PCs can reach the main Office LAN PC and the Office 1 LAN PC. Great, everything is working perfectly. If you hover your mouse over the routing flags, you'll see that this route is being managed by OSPF. Thanks for watching. I hope this was a great lecture for you, but we're not done with OSPF yet. See you in the next video.